so let's do an example, not of a projection, but of something a little bit different. So we're going to parameterize the intersection of cylinders, and I'll give you the formulas for those. Okay, that was messy. Cylinders. There we go. Of the following cylinders, we have x squared plus y squared equals 1, and x squared plus z squared equals 1. Okay? So, let's see. So these both parameterize cylinders, okay? And one of them is facing in the xy direction. So it's kind of looking like somewhat like this, right? xy. So cylinder goes like this, but it's going to go up and down because there's no bound on z. And the other one goes in xz direction, so that would be somewhat like this, right? So we're going to go across lengthwise, and it's going to kind of, okay, this is a weird drawing, but anyways, so it's kind of going to intersect at some points, right? So anyways, our goal is to find how to phrase that, or how to parameterize this weird intersection, okay? So what we're going to do is work with what we have, basically, with what we're given. So from this equation here, we can kind of deduce that our x could be cosine t. We're just going to start off with this, okay? This is like a 1 cosine t, right? Because we're on the unit circle, basically. And then y could equal 1 sine t, okay? So now that we have that, that's because, so our cosine squared t plus sine squared t equals 1, right? So then, after we've reached this conclusion that cosine t works for our parameterization of x and sine of t works for our parameterization of y, then we have to figure out what is z going to be. So let's work with this equation now. So if we solve for z of t, or z squared, or z of t, z of t, we're going to subtract x squared from both sides. There we go. To get z by itself, so z squared equals 1 minus x squared, and then we have to square root both sides, right? And when we do the square root, we pick up a positive or negative sign, 1 minus x squared. Okay, so at this point, we're going to take the parameterization we decided on for x, we're going to plug it into this equation here, see what we get. So now we have z equals plus or minus square root of 1 minus cosine squared t, okay? And from this equation, the one that we obtained here, we can subtract cosine squared t from both sides, minus cosine squared t, so that we get a 1 minus cosine squared t here, and then on the left side we get sine squared t. So now, for this part, inside the square root, we can plug in a sine squared t instead. So now we have a plus or minus square root of sine squared t. And this, the squared exponent and the square root cancel, so we get z equals plus or minus sine of t. Okay? So that's basically it. We have our x, that's already circled, our y, and our z. So our final parameterization of the intersection, which fulfills both of these cylinders here, is r of t is equal to cosine t, sine t, and then plus or minus sine t there. Okay? And just a side note, keep this answer in mind. I'll box it down here at the bottom. So this is what we obtained by working with x squared plus y squared equals 1 first, but we could just as well have worked with our x squared plus z squared equals 1 first. We could have made x equal cosine t and z equal sine t, okay? And then continued through and then solved for x squared plus y squared equals 1. If we solve for y, then that would give us plus or minus square root of 1 minus x squared, continue, and get that y is equal to plus or minus sine t. So another valid parameterization, and as I've mentioned before, there are a lot of ways to name, or aka parameterize, the same things. So another valid parameterization could be the following. We could have cosine t plus or minus sine t, and then sine t. Okay, so this one also works as well. All right, so now for a last example, we're going to parameterize the circle of radius 2. So we're given that it has a radius of 2 with the following center, with center P equals 1, not a 1, sorry, -3, 1, 5, okay, and located in a plane parallel to, and this is a two-part question, so the XY plane and B is the YZ plane, okay? So we have two parts to complete here. Basically, all it's saying is that we have to find a parameterization for a circle of radius 2 with center here at this point P located in a plane parallel to first the XY plane and then the YZ plane. Okay, so let's do the part A first. So if we want to make it parallel to the XY plane, what we have to do is, remember, set our Z component to 0. Okay, so this is in order for it to not have any like component in the Z direction. So we have to set our Z equal to 0, okay, for our parameterization. So let's say, first of all, let's parameterize our circle, just the circle of radius 2 based at, or centered at 0, 0, 0. We're going to say it starts at the origin, okay? We'll just go from there. So that would be a circle of radius 2. That means you have a coefficient of 2 for our cosine t and our sine t. Okay, so we have something like that, and our z component, like I said, is 0. This one here is 0. But what we're going to do in order to add that center, so what we've graphed is something like, let's say it's something like this, right? So it's sitting on the xy plane, and here's our z. And then we want to make the center at -3, 1, 5. So let's say it's up here. So we want to move all of these up to this point, okay? So we're going to move them up like that, and we're going to obtain this circle up here. And we did so by adding the vector representation of the point. So -3, 1, 5 with arrow brackets, okay? So that parameterizes this circle right up here, which is parallel to the xy plane. So an official, like, final answer for this, for part A, would be r of t is equal to 2 cosine t minus 3, comma 2 sine t plus 1, comma 5. Okay? So that's it for part A, this thing right here, and now we'll work on part B. Okay, I'll continue this on the next slide. So part B, this one asks us to make, to parameterize the circle of radius 2 and centered at point P, -3, 1, 5, an xy plane, and then parallel to the YZ plane, okay? So this one means that our x component is going to be 0 for our original, like, the circle centered at 0 part. So what this means is that if we have our x, y, and z, so we want to make it parallel to the YZ plane. So we're going to center our circle like this. It's along the back wall. It's like facing us, and it has a radius of 2, okay? So r of t right now, just centered at the origin, is going to be the following. So our x component is 0, so we're going to have a 0, and then we have like we can make our y be the cosine part. So 2 cosine t, comma 2 sine t. So this gives us a circle of radius 2 on the YZ plane, all right, because we have our y component here and our z component there, and nothing is sticking in the x direction, okay? But now what we want to do is kind of like translate it or move it to -3, 1, 5, move our center up to some point, maybe over here. So we're going to move them all back like that, okay? So we're going to obtain this circle here, which still is parallel to the YZ plane, but now we're going to add on this vector, -3, 1, 1, comma, that's supposed to be a comma, 5. I try to get a little fancy and make it a 5. Okay, so then our final parameterization for this circle is going to be -3, comma 2 cosine t plus 1, comma 2 sine t plus 5. Okay? So that's basically it. We can even call this a different thing since it's parallel to the YZ plane. It's a little different than the one that we did before for part A, so I called it P of T instead. Alright, so that's basically it. I hope that helped, and good luck on the homework. Push button, pull the trigger.